Alright, so today's notes are over medians and altitudes of triangles. So our objective is to construct medians and altitudes of triangles and identify points of concurrency. We're going to continue to use coordinate geometry to find equations of lines. So we're going to start off talking about the median of a triangle. So the median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So let's look at this triangle ABC. So the medians are always going to start at a vertex and go to the midpoint of the opposite side. And I know that the midpoint means I'm cutting this line in half and giving it two congruent sides. So with your patty paper, go ahead and trace triangle ABC. So to create this midpoint that I've created on BC, I took my patty paper and I folded angle C on top of angle B. Remember, your lines have to match up. So I made a small little crease, and then I took my patty paper and put it back down on my triangle, and I made a mark where that midpoint was. And then I drew a line from the vertex to that midpoint. So go ahead and do the same thing for your other sides, sides AB and sides AC. Find the midpoint of AB, and then once you find that midpoint, draw a line connecting it to C. Then find the midpoint of AC and draw a line connecting that middle point to line B. So you should end up with a triangle that looks like this. I found the midpoints of each of the sides, and I know that midpoints means these are cut in equal parts, so this is congruent to this, and this is congruent to this, and this is congruent to that. And then I've drawn a line from the opposite vertex to that midpoint. So this point that we've created here is the point of concurrency, which we talked about last class period. And in this case, we call that the centroid of a triangle. So the centroid of a triangle is the point of concurrency of the medians of a triangle. We also call this the center of gravity, which we will talk about a little bit more next class. So there is a theorem that goes along with this. And the theorem says that the centroid, this point of concurrency, which we'll call X, the centroid of the triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So that means that from A to X is equal to 2/3 of from A to, I guess we'll call the midpoint of this opposite side P, from A to P. This length right here is 2/3 of this whole distance. This part's 2/3, this part would be 1/3, the whole thing. So let's look at using that. So let's look at the first example. It says, given that I have this triangle ABC with A at -2, 5, B at 0, -1, and C at 8, 3, find the median, CT, in point-slope form. So go ahead and make sure you put your points on your triangle. So to find the median of CT, I know I'm going from point C to the midpoint over here, which would be T. So somewhere in the middle of here is T. So to find the midpoint, I know I take, if I'm looking for the midpoint of AB, and I am looking for the midpoint of AB because that's where T would be. So the midpoint of AB would be taking the midpoint formula. So x1 plus x2 divided by 2. And then y1 plus y2 and dividing that by 2. So that gives us a midpoint of -1 and 2. So the midpoint over here is -1, 2. This is point T. So I know that point T is going to connect to C because that is my median. So I'm going to draw a line connecting this. So what I need to do before I can write an equation for this line is I need to find the slope of CT. So remember, I can find the slope of CT by using the slope formula. y2 minus y1 over x2 minus x1. And so I'm using point C, which is at 8, 3, and point T, which we just said was at negative 1, 2. So it would be 3 minus 2 over 3 minus 2 over 8 minus negative 1. Now notice I put my y1s up front, and that's fine. I could have done 2 minus 3 and negative 1 minus 8. I've done the same thing. But this is going to give me 1 over 9. So my slope is 1 over 9. My point is negative 1, 2. So to use point slope form, I know it's y minus y1 equals m times x minus x1. So my y and the minus stays the same, and then I'm going to plug in 2 for y1. And that equals m, which is my slope, times x minus whatever my x1 is. And in this case, it's negative 1. So I know minus a negative is the same thing as plus a positive. So this would be the equation of the line in point slope form. All right, let's look at the next one. It says, find the centroid of triangle PQR with P at 3, 0, Q at 0, 8, and R at 6, 4. So go ahead and plot your points. So the first thing you need to do is find the midpoints of each of your sides, because I know that if I find the midpoints, my median always goes through that, and centroids are found by finding the medians. So let's start with the midpoint of PR. So midpoint, remember, is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if I'm using P and R, I'm doing 3 plus 6 and dividing that by 2, and 0 plus 4 and dividing that by 2. So the midpoint of PR would be 9/2, comma 2. And I know 9/2 is the same thing as 4.5. So over here I go 4.5 and 2, and this is the midpoint. So I can construct the median by connecting Q to the midpoint of PR. So that's one median down. So let's find the midpoint of QP. So the midpoint of QP means using P and Q, right? So 3 plus 0 divided by 2, and 0 plus 8 divided by 2. So 3 plus 0 divided by 2 is 3/2, which we know is the same thing as 1.5. And 0 plus 8 divided by 2 is 4. So let's see, 1.5 and 4 would be right about there. So I'm going to go ahead and draw a line connecting this midpoint with R. So then the last thing would be finding the midpoint of QR. So to find the midpoint of QR, I'm using these 2 points, Q and R. So 0 plus 6 divided by 2, and 8 plus 4 divided by 2. Well, that gives me the point 3, 6. So I'll come over here and find 3, 6, and put a point, and I connect this with point P. So now that I know that the centroid is where all these points connect, and that looks like it's at 3. So the centroid would be at 3. And it's 1, 2, 3, 4. 3, 4. All right, so the next thing we're going to talk about is the altitude of a triangle. So the altitude of a triangle is a perpendicular segment from the vertex of a line containing the opposite side. So we're going from the vertex to the opposite side at a 90-degree angle. So something that looks like this. So to create the altitude, you need to first, on your patty paper, construct triangle FDE. So once you've constructed FDE, to find this altitude coming from FE to FE from D, I take my triangle and I'm going to try to fold this line on top of itself, where D is where my fold is of the line. Okay, so I'm putting FE on top of itself. I can see the line is on top of itself, but I need to make sure the crease in my paper is at D. So I crease my patty paper at D, and I still see down here that my line is over itself. It's not like all crooked like that. It's straight on top of itself. Then I unfold the paper, and I put it back down, and I trace the crease coming from D to the opposite side at 90 degrees. And we'll practice this a little bit more in class because that was a little bit hard to explain on video. And we'll actually do the rest of them in class where they all cross. Because sometimes the altitudes are not inside the triangle. Because our altitudes may end up being outside the triangle. Like out here. Because when I bring this line straight down, it's probably going to meet out here, okay? So we'll talk about that a little bit more in class. But the places where all the altitudes meet, that's called the orthocenter of a triangle, and it's the point of concurrency for altitudes. So the orthocenter can be inside the triangle, on the triangle, or even outside the triangle, which I was just kind of talking about. So let's look at our first example. So anytime I find altitudes, I'm obviously going to have to find a slope of a line and then find something perpendicular to that, because perpendicular means crossing a 90-degree angle, and it means a negative reciprocal slope. So this says, given I have triangle ABC with A at negative 2, 5, B at 0, 1, and C at 8, 3, find the altitude of BW in point and slope-intercept form. So I'm finding the altitude of BW. So that means I need B, a line going from B through AC that crosses AC at a 90-degree angle. So I need to start off with the slope of AC. So the slope of AC, so we just talked about on the other side and last class that slope was y2 minus y1 over x2 minus x1. And I'm using AC, so that's negative 2, 5, and then 8, 3. So I'm going to say that the slope is 3 minus 5 divided by 8 minus negative 2. And remember, minus a negative is the same thing as plus a positive. So that ends up giving me a slope of negative 2 over 10, which I can reduce to negative 1/5. But I don't necessarily need the slope of AC. I need a slope that's perpendicular to AC. So I know the perpendicular slope of this would be flipping this upside down. So instead of 1 over 5, it'd be 5 over 1. And changing it from a negative to a positive. So my perpendicular slope would be 5 over 1, which is 5. So then the next thing I need to do to find the equation of the line in slope-intercept form is I need to put it in point-slope form so I can solve for y and get it in slope-intercept form. So the point we're going to use is point B, which is 0, negative 1. So in point-slope form, this equation would be y minus my y1, which is negative 1, remember minus a negative is plus a positive. I don't know why I put that there. Equals my slope, which in this case is 5, parentheses x minus x1, which is 0. So this is the same thing as y plus 1 equals 5x. So if I solve this equation for y, that means subtracting 1 from both sides. And remember, solving for y is slope-intercept form. It's when y is by itself. So the equation of this line becomes y equals 5x minus 1. So if I were to graph that, and that means my line goes right here, and then I go up 5 points and over 1. And so the line that I've created would look like this. And it would cross AC at a 90-degree angle. Alright, so let's look at the next problem. It says, find the orthocenter of triangle JKL with J at -4, 2, K at -2, 6, and L at 2, 2. So I'm going to start out by finding the altitude from K to JL, just because it's the easiest one, because it can go straight up and down, and I can already see like where the altitude is, because this is a vertical line, so a horizontal line, this is a horizontal line, wow. So a vertical line would be perpendicular to it. So this is one of my altitudes. So to find my other altitudes, I have to write an equation for some lines. So I need to write an equation for a line going through JK that starts at L. So kind of like what we did up here, the first thing we need to do is find the slope of JK. Well, the slope of JK would be 6 minus 2 over -2 minus -4. So the slope of JK ends up being 4 over 2, which is the same thing as 2. So the perpendicular slope wouldn't be 2, it would be -1 over 2. So when I go to write an equation for this line, I say I have to use the point slope form to start out, right? Which means I need a point, and I know my point's going to come through L, because L is going to create an altitude going through JK. So I'm going to use the point L, which is at 2, 2, and the slope, -1, 2. So y minus 2 equals -1/2 times x minus 2. So when I solve this equation for y, I first have to get rid of the parentheses. And then I have to add 2 to both sides. So I have another altitude, So it starts at 3. My y-intercept's at 3. And the slope is -1 over 2. So up 1, this way 2. Up 1, to the left 2. And if I were to draw a line connecting those dots, I could do that. So there's another altitude. So let's do the next one a little bit shorter. Let's just find the slope of LK. So the slope of LK would be 2 minus 6 over 2 minus -2. So 2 minus 6 is -4, and then 2 plus 2 is 4. So that gives me a slope of -1. So if I'm finding the negative reciprocal, or the perpendicular slope, I know I would flip this over. So flipping -1 over 1 over would still be 1 over 1, but instead of a negative, it would be a positive. So let's go from point J and just use that slope instead of creating a whole equation. So I'm just connecting point J to all the new points I found with that perpendicular slope. And I see that all of these altitudes cross at -2, 4. So my orthocenter is at -2, 4. And that's all.